This one is water is a polar molecule, meaning it's a partial charge and at opposite ends.
Well, that was one of your first ones, wasn't it?
Yeah.
We want to drive 2 potassium ions and 2 bromide ions to where they would most likely appear based on the grouping of water molecules.
What was this one? We did the formula for a
So-
compound made from X plus.
With water, the dipole goes up towards the big.
So yeah, so we got the negative end right here, and then we got the positive end right there.
Okay.
Positive, negative, negative, positive, positive, negative.
So we want our bromine that's negative to be somewhere far away from the potassium since it's another bigger molecule. And we also want it to be on the negative.
So we got
Or the
potassium,
positive end.
which is K plus, and bromine, which is minus. Okay, so which one wants to go where?
Bromine wants to go on the positive end by the hydrogens.
So this one?
Yeah.
Yeah, so we're going to put the bromine right here because it's negative. We got the positive ends of the water attracted towards it. And here we have the negative ends of the water. Those are going to be attracted to the positive, to
Like that.
potassium, like that.
And it was spelled opposite. It shows. That one.
So this one is so predict the formula for a compound made from X plus and Y to the negative third power.
Okay, so if you have x plus like that, and y to the third power, I mean not y to the
It's
third, y
2 plus.
3 minus.
Two
Oh,
plus.
2.
No, that's good, that's good, that's good.
It's
The other one.
x2 plus and y3 minus.
Okay.
Okay, how would we write that one?
Well, what you could do is you could do the swoopy swappy rule. And so this guy will be x3, y2. Okay? Because the thing is that we need to get them to have a common multiple so that their charges canceled out. And so this guy's going to go up by 2's and that guy's going to go up by 3's. So you need a number that both of them can become, which is 6. So if you multiply this guy by 3, you would have a total of 6 positive. And you multiply this guy by 2, you would have a total of 6 negative. So those cancel out. So you're left with 3 of these and 2 of those.
Okay, that's 3. Okay, you can go.
So this is your other one that you already had. This is the solubility one. So the ionic compound.
Okay.
Lattice energy affects the enthalpy in solution, which can affect the solubility. So based on the ion sizes, rank them according to their solubility.
Okay, so
So
what's the ions?
we have NaI, NaCl, NaBr, and NaF.
Okay, so it's asking which one's going to be the most soluble of the bunch. Okay, so right now,
What is soluble? It dissolves in water?
it dissolves in water. Like, so we know that these are 2 ions, right?
It's easier.
We got an I and we got an Na. Okay, so the question is, which one is going to allow the water to enclose them more quickly?
So it's going to be the smaller ones, the smaller masses, right? Or is it with?
Is it?
Or is it based on the bonds?
It's based on the size. And it's based on the concentration of the energy. Okay? So let's take a look at these guys. Let's go ahead and put them in order. So I know that F comes first in the periodic table, and then comes chlorine, and then bromine,
Then
than iodine. So I know first of all that it's either going to be in this order or in that order. Okay? Because
It's based on size.
it's all trends. So the question is, which one would be able to be pulled apart easier by water? So we know that each of these guys, so basically we're comparing this. We can take out the NAs. Okay? We're comparing this guy, this guy, this guy, and that guy. Okay? So this guy we know is probably about that size. That guy is about a little bigger, and that guy's just huge. Okay? And this guy overall, he has a charge of -1. This guy overall, he has a charge of -1, -1, -1.
So
So which one has the charge more distributed, and which one has it more concentrated?
The most distributed is the eye.
Yeah, I has it the most distributed. So this guy actually, his charge, because it's over a wider area, it's a lot weaker.
easier.
Okay, it's a lot weaker. And plus the thing is, so this is what is supposed to hold it on to, help it hold on to the sodium ion. Okay? So the thing is that this guy being more concentrated, he's able to put a lot more energy into that connection with sodium. And so this guy, fluorine, he's actually he's somewhat insoluble in water. Okay? Whereas
Insoluble?
iodine,
Insoluble, like it means it doesn't dissolve.
it doesn't dissolve.
Oh.
Like if you have hydrofluoric acid is actually a weak acid because it won't break in water that easily. Okay? Whereas if you have HCl dissolves very easily in water. And even more easier to dissolve in water is HBr. Okay? And HI. Those are called strong acids because they dissociate. They like completely separate in water.
So strong acid can dissolve in water. It's one of its
Yeah.
characteristics.
They'll dissociate in water. So this guy, iodine, that's going to be the one that's going to be the most soluble in water.
Okay. So the smaller is, the more it doesn't want to dissolve.
So what is
Yeah.
the question asking?
Opposite.
Based on the size, rank the compound by their respective solubility in water. Okay, so the eye is actually first.
The eye should
Oh, but
be.
you have
Yeah.
different ones. Yeah. Okay.
Well, it is the same.
Yeah, you're right.
Which ones do you have?
Or did you have different ones?
It's just like 30 questions. I just don't want to look for it, but I still want to learn it.
Yeah.
Like
Yeah.
30 questions on that.
So yeah, it's going to be the one that's the biggest, the one with the biggest radius that's going to dissolve the fastest. Did you try it?
Yeah.
Oh, perfect.